Hello guys, welcome to our channel. I am Lara, and in this video we are going to talk about Vertex P-Center Problem. Let's get started. What is Vertex P-Center Problem? The Vertex P-Center Problem is a network-based facility location model that aims to minimize the maximum distance between demand nodes and their assigned facilities. Unlike continuous location models, facilities in the Vertex P-Center Problem can only be located at predefined network nodes or vertices. Okay, so the goal here is minimizing the maximum distance. That means minimize the farthest service distance in the system. The model focuses on fairness, accessibility, and worst-case service quality. Why is it called Vertex P-Center? Because facilities cannot be placed anywhere and must be located only on network vertices or nodes. Examples for this are intersections, road junctions, existing buildings, and predefined candidate sites. Okay, so here we have the mathematical model of the Vertex P-Center problem. This will be discussed more thoroughly in the GAMS video. So for now, I'm only going to show this to you. If you want to examine this, please do. But we're going to solve a question about this. So a city plans to open emergency response centers on transportation network in order to improve service accessibility. Due to operational limitations, facilities can only be located at predefined network nodes. The city wants to minimize the maximum distance between demand nodes and their assigned emergency centers. The network contains 5 nodes. The city can open 2 emergency centers. Okay, so to solve these questions, we have to look at this matrix that is given. So it shows the distance, units of distance between a node from another node. And we have to create a set with 2 facilities. So because we can only open two of these facilities, we are going to look at which 2 can be opened. So A and B can be opened together. A and C can be opened together. A and D can be opened together. A and E can be opened together. Then we have B and C that can be opened together. B and D can be opened together. B and E can be opened together. And then we have C and D can be opened together. C and E can be opened together. And lastly, D and E can be opened together. So we have 10 sets that can be chosen from. Okay, so let's start with A and B. What we're going to do is we're going to write the node. We are going to write the closest facility, and then we are going to write the distance. So what do I mean with this? So for the nodes, we are going to write all the demand nodes. So A, B, C, D, E. And then because our first set is A and B, we are going to look at which one of A or B is closest to all these demand nodes. So what we're going to do, we are going to look at these A and B values, and we are going to select which one of them is the closest. So for A, the closest facility would be, of course, itself A, and the distance is 0. For B, it would be again itself, so B, distance is 0. For C, we're going to look at 7 smaller of 5. 5 is smaller, so the closest facility to C is also B, and the distance is 5. For D, same for B, D, it's 8 units of distance, and for E it's again the same, B with 11 units of distance. So what we're going to do here is we are going to minimize the maximum distance. So here we are first going to look at the maximum distance. It would be 11. So 11 is going to be our V here. So the maximum distance. Okay, so let's write this somewhere here. AB, for AB, W is 11. Okay, so our next set is going to be A and C. So for A, the closest node is going to be itself A with 0 units of distance. For B, let's look, it's going to be A with 4 units of distance. For C, it's going to be itself C with 0 units of distance. For D, it's going to be C with 6 units of distance. And for E, it's going to be C again with 9 units of distance. So we have to find the W here again. So the maximum distance, and it's going to be 9 here. So for AC, it's going to be 9. Okay. So for the next set, we have A and D. So for A, it's going to be itself again with 0 units of distance. For B, it's going to be A with 4 units of distance. For C, it's going to be D with 6 units of distance. For D, it's going to be itself, the closest facility with 0 units of distance. And for E, it's going to be D with 4 units of distance. So we have to calculate W here again, the maximum service distance, which is going to be 6. Yep, 6. Let's write that. AD, W here is 6. On to the next set, it's going to be A and E. So the node closest to A is going to be, of course, itself. So A with 0 units of distance. To B, it's going to be A again with 4 units of distance. For C, it's going to be A with 7 units of distance. And for D, it's going to be E with 4 units of distance, and for E, it's going to be itself with 0 units of distance. So W here, so the maximum service distance is, the maximum is going to be 7. So let's write this here. AE, the W here is going to be 7. To the next set, which is B and C. So the closest facility to node A is going to be B with 4 units of distance. To B, it's going to be itself with 0 units of distance. To C, it's also going to be itself with 0 units of distance. To D, it's going to be C with 6 units of distance, and to E, it's going to be C with 9 units of distance. So W here is going to be 9. B, C, which the W here is 9. Okay. On to the next set, B and D. So for A, the closest facility is going to be B with 4 units of distance. For B, it's going to be itself with 0 units of distance. For C, it's going to be B with 5 units of distance. For D, it's going to be itself with 0 units of distance. And for E, it's going to be D with 4 units of distance. And the maximum here is going to be 5. So BD W is going to be 5. So the next set is going to be B and E. Yeah, so for A, the closest facility is B, so with 4 units of distance. For B, it's going to be itself with 0 units of distance. For C, it's going to be B with 5 units of distance. For D, it's going to be E with 4 units of distance. And for E, it's going to be itself with 0 units of distance. So let's write that down. W is going to be, so the maximum is 5. Going to be 5. So let's look at our next set. It's going to be C and D. So the closest between C and D to A is going to be C with 7 units of distance. To B, it's going to be 5 with C with 5 units of distance, and then C, it's going to be itself with 0 units of distance. For D, it's going to be again itself with 0 units of distance, and for E, it's going to be D with 4 units of distance. So the maximum service distance is going to be 7 here. So C and D, W is 7. So the next set is going to be C and E. So to A, the closest is going to be C with 7 units of distance. For B, it's going to be again C with 5 units of distance. For C, it's going to be itself with 0 units of distance. To D, it's going to be E with 4 units of distance, and to E it's going to be itself with 0 units of distance. The maximum service time here is 7. So CEW is 7. Now the last set, D and E. Okay, so for A, the closest is going to be D with 10 units of distance. For B, it's going to be D again with 8 units of distance. For C, it's going to be D with 6 units of distance. For D, it's going to be itself, it's 0 units of distance. So for E, it's going to be itself, it's 0 units of distance. And here W is going to be 10. So for the E set, W is going to be 10. So what we are going to do now, we are going to look at all the W's that we have found and select the minimum. And that's going to be, what this means is this question has 2 optimal solutions. And these solutions are selecting B and D together or B and E together. So this is the optimal solution. Okay, so this is it for the video. Thank you for watching. If you want to test yourself, if you have learned a lot or not, you can scan this QR code and test yourself. Thank you for watching. See you next time.